Hey guys, okay, we're going to start our flip lesson for chapter 4. This is 4.1. There are 5 sections in chapter 4, and we're just going to do the first one tonight. How did the atomic theory develop and change? So we know atoms make up everything. The atomic theory ended up growing as we found more out about it, obviously through better technology and through more theories and models and experiments. We were able to figure out more about each theory. It started with Dalton. He said that we have the small spheres, and that was an atom, and that was the smallest part, and that was it. They weren't made of anything else. They were just atoms. After him, Thomas came around and said, okay, you've got positives and negatives on that sphere. So it's just a small smooth sphere that had just positive and negatives on there. Then Rutherford came in and shot some positively charged particles here. If you look here, shot some positively charged particles onto this gold foil. Well, some of it bounced back, and some of it went through. So what he said was, okay, the atomic model has a positively charged nucleus. That's why these bounced back, because it hit this small area in the center, but most everything else went through the outside. So it must be the nucleus is positively charged and you got these electrons on the outside. Then we have some other theories that came about, and the modern atomic model, it says that we have a nucleus and it had some protons and it had some other stuff. We didn't know what that was at the time. And we got electrons on the outside in a cloud-like region. So the modern model of the atom looks like this. We got a tiny, tiny, tiny nucleus, but it has most of the mass of the atom. A very tiny nucleus, but most of the mass. And it has the positive protons and the neutrons, and then you got the electrons in a cloud-like region, and they're constantly moving. The model of a carbon atom, for instance, looks like this. It has a little tiny, tiny, tiny nucleus, and we have neutrons and protons here. Neutrons don't have a charge. That's why there's no plus or minus on it. And then a cloud of electrons. And those are negatively charged electrons. So when you look at the mass, when I say the nucleus is so massive, when you look at an atomic mass unit, an AMU, protons, they have 1 AMU, and neutrons have 1 AMU, but electron is super, super tiny. That's why the mass is mostly in the nucleus, which contains these two items, the protons and neutrons. And the electrons swarming around, you can almost think it like a hive. And this is the hive, the protons and neutrons, the nucleus. And then the bees are teeny tiny swarming around the outside, and they have hardly any mass at all. Isotopes, when we talk about isotopes, it's saying that carbon has, for instance, every element of carbon, or every isotope of carbon has 6 protons, no matter what. In this isotope, this is carbon 12, we have 6 neutrons. In this isotope of carbon 13, we have 7 neutrons, because we have 6 plus 7 equals 13. That's where we're getting that carbon 13 or carbon 12. And so in carbon 14, 6 never changes, and so this has 8 neutrons, because 6 plus 8 is 14. And we'll learn more about that as it goes on and how we figure that out. But carbon 12 right here is the most common isotope. That's it in section 1.